So in the fall of 23, we submitted an application for a grant, and we received the application back successfully in the fall of 24. And at that point in time, we had a get together where we decided what we're going to do, and this is what we ended up with. It's the I'll show you the actual what we've got, which is this is a picture of it right here.
It'll come back. Now it's come back to 100. Use these tiles. I want you to have this up and looking at it so that you can actually see these values. And if you see the values change, you know that you've got the right, that you're doing the right thing. If they don't change, then we have a problem. Here's the same thing for the blue, yellow, and orange, and its watch table as well. So that's getting you through the verbiage of this week 8, but now I'm going to show you a little bit about how these programs actually work. And this is all given to you, and from this point on, it's going to be some suggestions. So week 9 is not another program. So this is the last program I'll give you, but then week 9, I'll start giving you suggestions on how to do the various things. So that's that's the process we're going to go through, see how that works. Hopefully that works, and if it does, you're launched as far as being able to solve the Rubik's Cube. So that's basically the idea here. So we're going to shut this off. We're going to come back and we're going to look at the program. And right now I've got the watch table up and running, but let's go back and let's look at the screen. So this is the screens that you have, and this would be the screen that you come up with the very first one. And I'm just going to show it to you and kind of overlaying the running program in the background. And you can look at the watch table, or you can look at various parts of this program as you see it. And when you're online and you have the glasses on, you can see the various things going on. Now, I've already clicked this to on, but when you first see it, you're going to have to click this button right here, and it'll turn on. And then you click reset, and then you move through the motors using this switch right here. This would be give you the white, the green, and the red. Now this is a relative move, and I put in numbers already here for it. It's 100, and I'm going to click the. I'm going to show you the picture of that right now. If I can get that picture over there to that and see if I can see it. Let's see if I can see it right now. Kind of small, but maybe I can see if I can get it going there and see if you can actually see it. Matter of fact, I'm going to increase the size just a little bit to see if you can actually see that on the screen as we're going through this. Okay, so we're going to go back.
This is the size of what you'll be helping to build. See these 6 daisy chained. Some of the wires are daisy chained, and some of them go straight over to these 6 stepper motors. So the wiring goes from the PLC to this block over here, these 6 motors, the motor controllers, and then it goes to the then from the motor controllers it goes over to the steppers themselves. What you're sending out here are pulses. And those pulses are converted into a move. So if you send 100 pulses, you're moving 90 degrees. And that's what that's about. So that gives you a little bit of an idea. So here's your programmable controller. The wiring goes from here over to here, and from here it goes over to there. Okay. That's what we're going to be building on Thursday.
We're going to try to see if we can get this to run now.
Maybe 5 of them.
The red one, and see the relative move, see if it runs, and it should run, and it's going clockwise. I want to do the white, and it didn't quite go 100%. Now, if that's the case, for the first one, you add a little bit, add like 105 instead of 100, do that, and then do it again, and it'll come back. Now come back to 100. It's a little sticky at times, so you might have to do that just to get us started. Okay, see that? It's working. Let's go to the next one. The green. You see that? Over here, do the blue first. See, these are just 90 degrees. And then I'm going to select the yellow on the bottom, and then the orange.
It helps that they got magnets in them.
Okay, now how do you get it to do something different than that? Well, let's go back to the white, which is on top. And let's say I want to go 200. That would be, instead of 90 degrees, that would be 180 degrees, right? Let's see what it does. Didn't quite make it, so we add a little bit, 210, to get it back in line. Then go back to 200. And it should be doing okay. Now, how do you make it go minus, or how do you make it go, this was clockwise, this is right hand, and let's think about how you would do the other. So let's go minus 100, minus 100. See if that does and I've got to get the minus number in there or it won't work. I've got to go on the screen, minus 100, enter, and see if that says minus 1. Now it does. Let's see if it goes the other way. And it did, but didn't quite go the whole distance, did it? So let's just do it again, 110. That went back to positive. Let's go minus 110. Minus 110. Okay, see if it does it. Okay, so it didn't quite go. Let's do it again. Now it's back. Okay, so we've got to do a little bit of work on that to make it work, but it's a, so you put the minus in front of it, you click enter, and then you say move, and it'll see if it moves, and it does move pretty well. For the most part, it works pretty well. Occasionally it's a little sticky, but that's, again, you're going to have to work on that and work on details. There is no feedback with these, so in other words, you don't have any way of knowing if they don't go quite that way, but you have to, basically, before you get started, you have to make sure that these are going at 90 degree spins. So now you've got an angle, now you've got a way of moving both positive and negative, either 90 degrees or 180 degrees in either direction, and the positive direction is clockwise, the negative direction is counterclockwise. Now let's click on the next button here. So I already filled in all the white, blue, red, blue, okay, but if you hit a knit, what you do is it starts again, and I want to start doing this again. Let's go orange, green, yellow, red, blue, white. Now that's filling it in backwards, but that's good. I don't really mind doing that. But what that did was it put my system, I'm going instead of going 1, 2, 3, 4, 5, 6, I went 6, 5, 4, 3, 2, 1, and I should be able to see that in my array. So let's go up here and look and see if my array says that, and it does say that. See, it says 6, 5, 4, 3, 2, 1, and that 7 is the one that's the black one, and that's the one that's the next one in line to fill in. So basically, now you're committed to doing something. So if I wanted to go 6, 5, 4, 3, 2, 1, and then I started here, 1, 2, 3, 4, 5, 6, I would then see that array from 0 through 12 now filled out, through 11 filled out. 6, 5, 4, 3, 2, 1, 1, 2, 3, 4, 5, 6.
You're supposed to be seeing this over here.
Okay, so now I've got to, and I also got to bring this back so that you can see this on my screen, because I forgot that I have all this stuff going like this. So again, I'm sorry about that. We're back to normal, but it's kind of like not quite normal, but it's close. But here I have now the picture of the 6, 5, 4, 3, 2, 1, 1, 2, 3, 4, 5, 6. And it goes, that's the array. That's how it's done, and it keeps going. So again, I don't want to beat you up with this, but I just wanted to show you that. Now, the black one is a 7, which is the next one in line to fill in. So on this screen as well, I wanted to show you that you can spin with the array called the spin. We'll talk about that later, but as you.
So this is the project that we're going to be working on, and the parts and pieces that we're going to be doing with the wiring harnesses for this. Okay, so we're just going to do this for a day. It's not like we're under the gun. I thought we were under the gun, and I apologize for that. We had 30 schools that we thought we were going to have to do this for. Turns out we're going to have to do it for 3 or 4 schools right away. We'll build these eventually and get them all built, but as of right now, today, we only need 3 or 4 built. So there's no pressure on you we got to crank out 10 of these today or whatever. We'll crank out a couple of them. But the goal for us is to be able to look at how you build these, how you build electrical components. And wiring components is nothing magical, but it does take a little bit of time. And we're going to take a day to do that. So, it's different. It's not what you normally expect. And you're not being treated like a slave where you'd have to crank out so many of these or else or whatever. We're not under the gun. We're just trying to give you an experience and also let you see what that you can do. The other side of this coin is this project has gotten a lot of interest in high schools. It's not like everybody is going to be doing this. It's not like everybody's going to be coming around and saying, wow, I can solve a Rubik's Cube using a programmable controller. But on the other hand, getting these into high schools, we have about 387 of these trainers in high schools. Now, that doesn't mean that 387 high school kids are sitting there working on these. Some of them are, some of them aren't. It's you sprinkle the salt out there and you hope that some of them actually grab hold of it and do it. It's not 100%, it's not 50%, it's probably about 20% or 30% actually do stuff with these. But it's not like we're not trying to get students to do this. And I want to show you, if you get interested in doing this kind of thing, like one guy said, he basically said, it made me a controls engineer. One project made him a controls engineer. Now, you may not agree with that, but you might look at it and say, well, that's interesting, because what you at the end of the day have to do is, you notice that I was talking about this how you numbered the cells and the tiles on the cube. Well, there's the numbering of them. Okay, I had to number them, and I put this into an array. And if you look at it logically, you say, okay, now there is an array of positions. And if you put a color or a number in each of these slots in this array, and you say, okay, that would maybe be a 6, that would be maybe I don't know what the color arrangement was. Orange is 6, green is 5, white is 1. So if you put a 1 in there, that would be a white tile, okay? So you're representing physical things with things that you can control. And that's kind of how you have to work in an industrial environment. You have to start looking at how you can arrange things so that they're meaningful, so that you can control them. And maybe this has nothing to do with anything you ever thought you'd ever end up doing, But this is how you start thinking in terms of how do I control something like this? Because every time you spin one of these, the colors change the position. So your colors would then have to rotate, and I already wrote the programs, and I gave them the programs to do that part of it. So if you want to rotate 90 degrees, these colors have to be moved from, like 5 has to go to 8, 6 has to go to 11, 7 has to go to 13, that type of thing. So, and I wrote that part of it already, I gave it to them. But that's what we're talking about there. The harder part of that whole thing is, and I'm not going to do my whole lecture on this, it's just a little bit of, me jabbering, but I want you to understand that this is what a few people have said has basically helped make them feel comfortable as a controls engineer. So you look at the Rubik's project, how to solve it from a person who's trying to teach you how to solve a Rubik's Cube. Now you look at it from holistically from that point of view, and you say, what did these experts say? And you say, okay, what did they basically come up with? Well, they came up with steps: the white cross, the white corners, the second layer, the yellow cross, the yellow edges, the permuting of corners, and the orientation of corners. And those are the 7, 1, 2, 3, 4, 5, 6, 7 steps to solving the whole cube. Okay? Now that's not necessarily the best way of solving it, but it is an orderly way of solving how you solve the Rubik's Cube. So the white cross is the first one. Let's just concentrate on the white cross for a second. So how do you solve the white cross? Well, my approach to solving the white cross is this. And I didn't do it. I physically did not write the program, but I did show word by word by word how you actually solve that. You say, if the whites, okay, so there's a white and a green. Okay, so there's a piece that's a white on one side, green on the other, right? So let's go find it. How do you go find it? Well, you say, here's the array position, and here are the colors, and do I find the white, green in that position? Okay, so I say, in this tile arrangement, did I find the white and the green? If so, what do I want to do? Now, this part over here is called the discovery part, or the part that actually is the finding of the part. This part over here is after you've done it, what are you going to do with it? And you might have one where you find it, and then 3 or 4 where you have, what are you going to do with it? And that's the part where you actually say, I'm going to spin it. I want to do something with it. So if you don't find it, you just go to the next word. So this is what this is about. So if you don't find it, you go to the next word. If you do find it, then you do something with it. Does that make sense? So that's the orderly way of starting to think about how to solve the white cross. Nothing more than just the white cross. But now I've got a method for going through and solving the white cross. Does this impress anybody, or does this just make you want to never do anything with controls again? But do you see how I explained it? Does that make sense? Kinda? Do you see how you can convert something from, this is called algorithms, by the way. This is a practical algorithmic approach to how you can convert something that is physical into something that you can control. And that's what you want. You want to be able to take something that is physical, a machine. What is it about a Rubik's Cube? Very easy to define. What do you have to do with it? Put it back to its original position, right? It ain't easy. And everybody knows that. It's not easy. But here are logical steps. You click on that, it tells you how to do the white cross. Okay? Basically, it tells you that the first thing to do is to get, and I don't want to keep going, but to get the white green here, get the white red there, get the white blue there, and the white orange there. Okay. Now the white green part, you have to go out and find it where it's at. And then you move it around. The first part is to get the white green part into what we call the green plane, which is to move from someplace over here to in this plane. Get it into the green plane. And then from there, move it to its final position. That's basically the steps. And he shows you, the algorithmic guy that shows you how to solve this guy down here, he shows you how to get from the green plane to its final position. That's all he does. So it's up to you to define how to get into the green plane. And then from that point, you click on this little guy. You click on this little guy right here, and he'll tell you how to get from the green plane to the final position. I'll tell you how to do that. And basically you program that in and you're done. Easy peasy, right, Adam? He did it last year in high school, so he's a guinea pig. He was one of the people that actually did some of this and got some of it to work. So anyway, that's neither here nor there, but that's what this is about. Now, you don't have to, in this class, know anything about this for a test of any kind. I'm just giving you this because what you're going to be doing on Thursday is just one little part in getting this ready for high school students. And it's kind of fun. It's a very different, and basically you'll be given everybody that shows up will be given a grade of 20 out of 20 for participating, and we'll go from 8 o'clock to approximately 10:20 or whenever your lab's over, or in that range, whenever we drift off or whatever, however you decide what you want to do. But for 2 hours and 20 minutes or so, we want to do maybe 11 o'clock. I don't know, maybe 3 hours. Depends on where you're at. But for in that period of time, we want to try to wire some wiring harnesses, and we're not going to get it finished to the point where it'll spin, but we want to get it maybe close enough. Maybe we can spin an axis. I don't know. We'll see. Okay. Any questions? Any comments? That's a totally different thing than what you've done up till now. But again, I want you to understand what it's for. It's for high school students, and they're supposed to be learning some of this. I doubt if many of them are, but on the other hand, a few of them really are involved in it, and that will help them down the road. Now, if you're a high school student around in this area, some of your high schools now have this that didn't have it a year ago. There's about 30 schools that did not have this equipment a year ago that now have it, and altogether we have 34 schools that are doing this in some manner or whatever. Now, I know that some of them aren't doing very much with it. They took the equipment and they're, I don't know what they're doing with it, but that's up to them. Anyway, any questions? Any comments? By the way, any questions in general? I sometimes just totally forget to ask you, do you have any questions about what's going on or the course or anything like that? Because when you say we're about out of this book, we're about done, and yes, we are, and we have plans beyond this book, but this book is almost history. We haven't quite finished it off, but it is. And I don't want to say anything negative about the book, but chapter 9 is probably the worst chapter of all the chapters you have. And I'll be blunt. This is the one chapter, well, chapter 9 and chapter 10 are the two chapters that we're going to partially, I just don't want you to get messed up with how you want to say it. I don't want you to try to figure all of his stuff out because it's not worth much. Okay? So chapter 9, there's a little bit in there, and there's chapter 10, which is totally, again, I'm going to go a different direction in chapter 10 than what he does. But that being said, it's a good book, except for chapter 9 and 10. It's okay, except for we're right into it right now. Okay, so this is our book, and that's the wrong book, Ted. So we're into chapter 9. Okay, he has some arrangements of power supplies, and there's the Y and there's the delta. And then we talked a little bit about this the other day. And this is, so he kind of refers to this as the delta and this is the Y. But I, I kind of refuse to get involved with his, because he's very confusing. I honestly think that you're better off just learning the basic formula here for this is your phase to ground, and I explained a phase to phase the other day. So if you didn't get that, he proves to you that the relationship between the phase to phase and the phase to ground is a square root of 3. And that this is his proof, and it's a very good proof of that. If you can't follow the fact that what I just told you the other day, just take my word for it that the difference between the length of this vector and the length of the vector that goes from here to here, which is this vector right here, is the square root of 3, he proves it to you. Okay? So this part right here of a 60-degree triangle, bless you, is a square root of 3 over 2. And this is a square root of 3 over 2, but you add this to this, what do you have? Square root of 3. Okay? So the length of this vector with respect to the length of this vector is a square root of 3. Okay? So that being said, you're always going to be looking at phase to phase. You're not going to be looking at phase to ground. But how you hook these up determines whether you use, in his case, the square root of 3 or just 3. So the power, in some cases, see, he uses as 3 times I squared R, and in some cases, he uses square root of 3 times. So basically, it depends on whether you're measuring the voltage, this voltage or this voltage. There's your square root of 3 difference. And I don't want to get you confused on that. And that's where you can get very confused. Okay, so that gets you to the point where you say, help. And he goes through several of these examples, and I just refuse. This is your Y connection, and he shows you how to do with the Y, and here you go with the 3. And this time he uses, he says V line is equal to the square root of times V phase. So this would be the shorter one, and this would be the longer one. And then he says V line times square root of 3 times 240 is this. So that gives you this is your short one, this is your long one, okay? And then he says this. Now this is your power, which he says V. This is your shorter one. So it's 3 times the current times the shorter one. Okay? It would be square root of 3 if this was the longer one. Very confusing. But most of the time we say the power in 3 phase is equal to what? Square root of 3 times I times V. And this V is the phase to phase. Or the longer one. Okay? But if you say this is square root of 3 times the shorter one, he's square root of 3 times the square root of 3 is 3, and that's why he gets this number 3 here. Does that make sense, everybody? Because the square root of 3 times the square root of 3 is what? Last time I heard it was 3, right? If you take the square root of 3 times the square root of 3, what do you get? 3. And there's the 3. But most of the time we do this. But in this case, he uses the shorter of the two, so he uses not the longer one, he uses the shorter one. So that's why it's 3. So again, I don't want you to be confused. I want you to always remember this is the right one because this is the one you will use. Why? Because you will not go phase to ground. You will measure across from phase to phase. In other words, you have 3 wires coming out of there, and each one of those is one of your phases. So you're going to measure from phase to phase. You're not going to go phase to ground. It doesn't work. Another reason is because sometimes you're off of, you're off center. In other words, you might be a little bit like this, and there's your ground, but you're over here a little bit. So you can't measure from phase to ground, because this is where you're supposed to be in the middle, but this is actually ground over here. This is actually ground. It's not true ground. So you can't go phase to ground. You got to go phase to phase. Again, don't be confused. Take my word for it. We go on. However, in this whole scheme of things, there is something you really need to know. And it's not something you need to know today, but you do need to know it, because it will help you immensely if you take the PE test. Okay, so this is a problem like the problems in this chapter, except it's not exactly the same. But you're restricted from taking the PE test unless you get a master's degree. And you can go ahead and get a master's degree from here in electrical engineering, or you can get it in the online master's degree program. Everybody understand that? So if you want to get a master's degree, there's two approaches, at least, to getting a master's degree, all right, in engineering here. So one would be to get the master's MS EE. Most of you, if you keep your grade point up, can apply and get accepted in the master's program in electrical engineering. They'll accept you in, okay? So I'm not looking at people here who can't get a master's in electrical engineering. You can. Also, there's a Master of Science, just a Master of Science in Engineering, okay? And this is an online degree that will give you a practical master's in engineering. And from that, you can, and these are all online courses, and from that, you can go out and you can have a master's degree in engineering. So on top of your technology degree, if you want a master's in engineering to hang on the wall, there it is, okay? And it's a very good degree. It will help you get a master. It will help you in being a, how do you want to say this? If there are encumbrances to getting a bachelor's in engineering technology as opposed to engineering, which most people do not have any problem with, they say, if you can work and do the job, we'll accept you, no problems at all. However, in government jobs, sometimes there is, well, you don't have a blah, 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 you don't have this, you don't have that. That will knock that in the head, okay? So you can get a master's in engineering from here with that, with this bachelor's degree. So, all that being said, in 4 years after you get a bachelor's degree with a master's, so after 3 years after this, after you get that degree, or 8 years after you get a degree in engineering technology, you can apply for and take the PE exam. Okay? Now, most of you say, I don't care, I don't want to do that, I'm not gonna worry with that. Some of you will. And I'm not looking at people who can't do that, I'm looking at people who can. You can. Okay? But I took the PE exam and I camped on these problems because they're easy. You say, but what I'm going to explain to you right now is one of the keys to becoming the word PE, okay? So I camped on doing these problems. Now, what kind of problems are they going to ask you at the PE level? Hard math problems. They think they're hard. I personally think they're not. Because if you can knock these in the head, you can go through, if you see these, you can go through them in about 20 minutes with this calculator, and they call you a PE, okay? So there's, when I took it, which is a long time ago, but I don't think they can't change it very much because they just can't, all right? If they ask you a practical question, there's so many ways to answer it. But these questions, there's one right answer, and they'll grade you off almost totally if you don't get the right answer. But it's easy to get the right answer, okay? Now, they always ask questions in economics, and it's the price of money. It's the calculated value of money. And there's a present and the future, how much money is worth, and you have to assume an inflation value over the course of time. But if you do that, those are simple plug and chug problems, and you get 1 out of 4. There's 4 questions in the morning, 4 questions in the afternoon, and you get to pick from a list. So there's 4 in the morning, 4 in the afternoon. You get to pick from a list, and you get 1 in the morning and 1 in the afternoon. So there's 25% of your test right there. Okay, that makes sense. So easy calculation of the present and future value of money. And again, what you take notes for right now will only come up in 4 or 8 years for you after you graduate. So the clock starts the day you graduate, either 4 or 8 years from then, you can take this test. So the notes you might make today, you just tuck away and say, no, what did he say? Okay, but now I'm going to show you one that you can probably get two questions out of the way of. Now, that maybe one, maybe two, but this is a question that I asked that in the morning and afternoon, and I don't remember if it was one or two, but I was able to knock out one of them. Okay, so this is the question. It's from chapter 9, by the way, and you're not going to believe it. It's an unbalanced phase. It's an unbalanced load. Okay, this is called an unbalanced load question. Okay. Now, up until now, everything has been a balanced load, right? Everything has been three phases and they're all balanced. What they do is they make them unbalanced, okay? Now, how do you solve an unbalanced load problem? Well, this is how you do it, okay? And you say, who gave you the keys to the kingdom? Nobody did, but this is how they do these things. And I'm just going to tell you that, that just write these notes down, put them away, and say, or maybe you don't care. Maybe this is not something you're interested at all in. But on the other hand, these are easy. Okay, so unbalanced load. And by the way, this is not going to be on any test. I'm not going to ask you this on a test. So this is not something you're going to be responsible for to me. It's going to be something you can tuck away for whatever. And you might get one of these, you might get two of these. I don't know, and I can't promise you what you're going to get, but you say, well, what are the other questions? Well, the other questions come up in EET 3250, right? That's the other ones. So you say, so if I get this and then I get 3250 and I get those answers done, I'll be able to be a PE, and the answer is yes. And the economic question, yes, you can. Two questions from EET 3250, one from here and one from the economics, and you're done. Or two from here, one from the 3250, whatever. But between the two of them, you can knock this test in the head and not have to. And by the way, I'm going to advise you on one other thing. Do not advertise the fact that you're taking it. So if you're taking the test, don't make it a big deal. Don't tell all your friends. Don't tell all your enemies, because they will ask you, did you pass? And if you didn't pass the first time, it'll always be on your record. Well, you didn't pass it the first time. I don't care. I was sitting there with people who have taken it the 8th time. I passed it the first time. Yay! But there were people there that were taking it for the 8th time. Oh my goodness. So don't advertise it. Don't make it a big deal. Just go and take it. And if you don't get it the first time, note what they did or didn't ask or whatever. So get smart is what I'm saying. Don't make it a big deal, and don't try to, don't feel crushed if you don't get it, but also work your butt off so you can get it if you want it, okay? Now, does this look familiar? Yeah, it does. This looks exactly like what we've got in this chapter, right? This is a three-phase load. Now I'm going to go up here and I'm going to attach, and I don't care how they do it. They basically have three phases, and now you're going to go 3 phases, and you're going to put something in each of these that is not standard, okay? So this is going to be 5 plus J6. Again, I don't care what I put in here, but I'm going to put something in here. Put something in here. Now this is unbalanced. 10 plus J2. And down here, I'm going to put in 4 plus J8. Okay, now that's an unbalanced load. Here's one, and here's one. And that's all it is. Okay, so that gets you that. Any questions so far? How are you going to solve this? The old answer is very carefully. You're going to use loop equations, okay? You can do this, I1. This is going to be I2. This is I2. This is I3. So you're going to write, and you're going to forget about this one over here because it really doesn't matter. So this is your loop 1. So how do you write loop 1? Now, if you come into it from the plus, you write plus, right? So you write down here 120 at, oh, this has got a 120 and 240. And I didn't finish this off. Okay, look at this. This is 120 at 120. This is 120 at 240. So I come in from this side and I write, when I'm looking at the I1 loop. So I'm just looking at the I1 loop right now. Okay, so I'm looking at the I1 loop. Okay, so here I come in at right here, and I come in at 120 at 240. I go right up here, and then I come here, and it's plus what? Parenthesis I1 minus I3 times 5 plus J6 equals 0. What about the second loop, the I2 loop? I come in from the plus side, so I write plus. That's 120 at 120 plus, I come over here, and it's I2 minus I3 times what? 4 plus J8 equals 0. And up here, I've got a lot of stuff going on. I've got okay, so I start up here, come in from this side and go around like this. So it's I3 minus I1, parenthesis, 5 plus J6 plus I3 times 10 plus J2 plus I3 minus I1 times what? Let's get I3 minus I2 times 4 plus J8, okay? Equals 0. Now what do you do next? Sort and sift. No, sort and sift, root, okay? So now what do? The I1 terms, I1 times something plus I2 times something plus I3 times something equals something. Okay, so I1 is 5 plus J6 plus I2 times 0 plus I3 times minus 5 minus J6 equals what? Minus 120 at angle 240. The second equation, I1 times what? 0 plus I2 times what? 4 plus J8 plus I3 times minus 4 minus J8 equals minus 120 at angle 120. The third equation, I1 times minus 5 minus J6 plus I2 times minus 4 minus J8 plus I3 times 5 plus J6 plus 4 plus J8 equals 0. Now what do? What's I1? Well, you take, in this case, the right side and write it into the I1 column. So it's minus 120. So you take what's over on the right. This is called Kramer's rule. If you don't believe me, look up in Seinfeld, Kramer. This is Kramer's rule. It really is. This is called Kramer's rule. And not that Kramer, but this is a rule by a guy named Kramer. Okay, Kramer's rule. You take the column, if you want I1, you take the column over on the right and put it into the I1 column. So you take it and you say minus 120 at angle 240, minus 120 at angle 120, and 0. And then the other two columns are the columns that you have here. So the I2 column would be 0, 4 plus J8, and minus 4 plus minus J8. Does everybody see that? That's what you do. Now, this column, then this column is 0, 4 plus J8, and minus 4 minus J8. And what's the third column? Well, it's this part right here. It's this right here, this right here, and this right here. And now you can combine these. Okay, so it is minus 5 minus J6 minus 4 minus J8. Everybody see why this is a hard problem? Because it's got a lot of steps. That's all it is. It's just a lot of steps. 9 plus J14 over, then in the denominator, you don't do this, you do it normal. So in the denominator, you do 5 plus J6, 0, and minus 5 minus J6, 0, 4 plus J8, minus 4 minus J8, minus 5 minus J6, minus 4 minus J8, 9 plus 14 J, or J14, okay? The J can either be in the front or the back. Now, what do you do here? Well, from this point on, you recopy the first two columns. So you take this column, put it over here, minus 120 at angle 240, and then minus 120 at angle 110, 120, and then 0. And then the other one, you bring this column over and put it right there, okay? Now, what do you do from that point on? And then you do the same thing down here. 5 plus J6, 0, minus 5 minus J6, and then 0, 4 plus J8, and then minus 4 minus J8. Now, what do you do next? Now you're set. All you got to do now is do your multiplication, your cross multiplication. So now I'm going to do this in another color so you get the idea that this is the last one. And it is kind of an interesting step. I'll do it in blue, okay? So now you're down to this step. And again, this is just a big, long, burly problem, but it's not hard. It's very doable with what you've just done in this chapter. It's this times this times this plus this times this times this plus this times this times this minus this times this times this, this minus this times this times this minus this times this times this. It's this times this times this plus this times this times this plus this times this times this minus this times this times this, this times this times this, this times this. That. The denominator is this times this times this plus this times this times this plus this times this times this. And a lot of times you get zeros, which wipes it out. Minus this times this times this, minus this times this times this, minus this times this times this, and you're done. Okay. You got a numerator over a denominator with complex numbers, which you can crank out because you learn how to do that. That's all this is. You get a numerator over a denominator, there's your I1, and you do your I2 the same way, and your I3 the same way, and you're done, and you're PE. Okay? Now, you're probably never going to remember this. Some of you are going to say, the heck, I don't want to do that. I don't want to have to set for this. And some of you are going to say, I will do this. So I don't want you to think that you're not able to do this. You are. Any questions anybody has about this? Can you do this? Yeah, you can do this. Sure. I'm going to rewrite this thing over here on the right. I'm going to redo it. I'm going to show you exactly what I1 is, and then we're going to crank out an answer and see if we can get it. Okay, because I didn't write it. I ran out of room. I'm going to redo it. Okay. I'll do it in black. I1 is equal to minus 120 at angle 240 minus 120 at angle 120, and then 0, then 0, 4 plus J8, minus 4 minus J8, and then minus 5 minus J6, minus 4 minus J8, and 9 plus J14. And then you repeat the first two columns. Minus 120 at angle 240, minus 120 at angle 120, and 0. And then the second column would be 0, 4 plus J8, and minus 4 minus J8. Okay? All that over 5 plus J6, 0, minus 5 minus J6, then 0, then 4 plus J8, and minus 4 minus J8, minus 5 minus J6, minus 4 minus J8, 9 plus J14, 5 plus J6, 0, minus 5 minus J6, 0, 4 plus J8, and minus 4 minus J8. Okay? Now, you multiply this times this times this, plus this times this times this, plus this times this times this. So the multiplication at the top is minus 120 at angle 240 times 4 plus J8 times 9 plus J14 plus 0 times minus 4 minus J8 times 0 plus a minus 5 minus J6 times minus 120 at angle 120 times minus 4 minus J8. This is the plus. This is the plus side, okay? Minus this whole thing here, which is, so I went this times this times this plus this times this times this times this times this times this. Done. Now the next one will be 0. You're going up this way. Minus 0 times 4 plus J8. See, I'm going up this diagonal. Times, anytime you get a 0, it's 0. Minus 5 minus J6. Plus, so it's a minus, and then everything in here is added together. So minus 4 minus J8 times minus 4 minus J8. So this is this column times a minus 120 at angle 240. Can you do this? Yes, you can. With your calculator, you can do this. And then the third one is this times this times this one. It's a 0. Plus 9 plus J14 times minus 120 at angle 120 times 0. Bracket. And you're done. That's the numerator. That's the numerator. And the denominator is just the same thing, only the first column is different. And you're done. Can you do this? Yes, you can. Do it very quickly and very efficiently with your calculator, and you've got an answer, and you're called a PE. Okay, so one of the rewards of this course is it sets you up so that you can do that and you knock that out very quickly. These are problems that are asked on the PE exam because why? They think you can't do them, but you can. Right? Anybody doubt that you can do this problem? It's easy. You just have to be careful. But it's very doable. With what you've learned in this course, this is very doable. Okay. So Thursday, we're going to be totally different. We're going to do something totally off the wall different. And then we're also going to be, then next week, we're going to do chapter 10, which is not going to be from this book. It's going to be from a different book. And we're going to learn how to do Bodie plots. And we're also going to start talking more in depth about the project. So the project is the other thing that you're going to be doing. And you got set up with that the other day up in 2350. And the code to get into 4350 North Engineering 2350 has a code that you can 4575 pound sign. We'll get you in. 4575 pound sign. We'll get you in. Huh? I wrote it on the 4575 pound sign. That will get you in. Okay? I wrote it on the thing. So you can get in there anytime and start working on this stuff. Now I'm going to give you limit switches. There aren't enough limit switches right now, and I'm going to also move over from, maybe we'll do this on Thursday, maybe we'll do it next week or whatever, but I'm going to move over the equipment that you need. You're going to need to solder a little bit, and we'll get the soldering out and do that. You can figure that out. The only thing about soldering that you have to remember is, and there's wire in there, and you can use please use the 22 gauge solid wire, even though, what's the difference between solid and stranded wire? Solid wire will break on you. It'll eventually break. So you shouldn't use it in an actual application. You should use stranded wire. But for us, we don't care, and you can bend it and it'll stay where you want it, and it won't fray on you. So it's a 22 solid wire, and you can use that to land on your limit switches, and you can use that for all your wiring, and it works. You don't have to go out and get another kind of wire or anything like that. 22 gauge solid wire works great for what we do. You don't use it in industry, and we're not going to use it on the Rubik's project, because those things get jostled around and those wires break and you got a mess. So anytime you use solid wire, it's for short-term bending and making something, but don't ever depend on it. Except big wire. Big wires don't break. Big solid wires don't break. But little solid wires tend to break. And every time, when you least expect it, it'll break. So it'll come loose or whatever. But for the soldering onto those limit switches, you need to make a physical crimp before. If you make a physical connection, it's a lot easier for a soldered connection to hold, because you've already got the advantage of the physical connection. So you usually try to twist it around the lead, which is a little bitty lead. It's not a very strong lead. But anyway, and then you need to mount your limit switches, and I don't tell you how to mount them. You just have to figure that out. We've got little nails that you can put in, and this is some I give you, but some of it you just have to kind of, okay, here's where this limit switch hits, and this is how this works, and all that kind of stuff, and you just kind of do it, and you get it. Once you get the limit switches in, and you figure out whether you're getting the normally closed or normally open, then that signal then comes down, and then you have to say, well, I needed it the other way, so I have to put the limit switch in the other way. That's why in my drawing, I put it going to a relay, which then with the relay, you've got normally open, normally closed contacts, so that you can, either way, you can pick one and choose which one you want. But I did that on purpose, because you might get the wrong one, or you might not get it wired right, and then with a relay, you can always choose from the relay which way you want to go. So I showed you the other day where that sheets are, and they're kind of crude. I thought about going back and making them a little bit better, professionally done, but those are handwritten scanned sheets, and you can read them. They're not that you can't read them. They're just not, they don't look like my regular professional self, right? They're just scanned, handwritten pages, and I thought that was good enough to give you a hint on how to get started. There is a shortcut way of doing it. Please don't do the shortcut way. Use the stuff that's given to you. Have a time delay. In the past, I've accepted if they didn't do it with a time delay, but please don't do that. I would much prefer that you do it with a time delay. So you get to the end, you time delay, wait for the transistor to change state, then you go the other way. We'll talk about the changing of transition states on transistors not next week, because we got a week of Bode plots. So we've got a week of chapter 10, and Thursday of this week we're going to be downstairs, and we're going to be working on stuff downstairs. So meet here, and then we'll walk downstairs, and we'll probably be in that. If you get here late, just walk downstairs. It's going to be in that room, I think, right when you know where the computer rooms are down in the technology area where those 3 computer rooms are down there. Y'all know where that, you know where the little lunchroom is that you could go to for that? Well, the room on the left as you're walking down that way, but kind of right next to the lunchroom is where we're going to be. And the one you can see in the window and you can see stuff where the technician works, all that kind of stuff. That's, I think, where we're going to be. So if you miss coming here and you want to come down there, just come down there and we'll. But the pressure is off. We don't have to produce 30 of these by 3 o'clock Friday afternoon. We don't. It'd be nice if we could, but each one of them takes about 2 hours to do. And if we get 1 or 2 done, piece of cake, that's good. And you'll see it being done. You'll get a little bit of chance to do some wiring, and you'll get a chance to see how wiring harnesses are put together, and get a chance to help. I don't know exactly what everybody's going to do, but there's 15 of you, and you get a 20-point grade. If you don't come, it'll be 0. So this is one where actually attendance is not only preferred, it's required. So we'll hold you there for about a couple hours, and if at 10 o'clock you want to stay for another hour or 45 minutes or whatever, 8 to 10, 10:30, 10:45, 11 o'clock, we'll say, okay, that's it. But if you gotta go at 10 o'clock, go. If you can stay until 11, 10:45, 11 o'clock, that's, again, if we have things to do. If we don't, you're free to go. Okay. Any questions? Any comments? See you downstairs. Okay? Thursday. Everybody, did anybody, I noticed several of you copying this down. Is this something you're going to tuck away? And yeah, it's worth it. Yes, sir. Say again? We worked it out? The whole thing? We got it to the standard form, but we didn't talk about this, did we? We didn't, okay. I'm sorry that, yeah. I thought we did some of it, but yeah, I want you, believe it or not, I want you to get this, because these are easy problems and they're on the PE test. I want you to be able to do this. If you want to do it, if you don't, that's okay. But I want you to be able to do this, and or else I wouldn't have probably done it again. Sorry.